Sorry dear friends, there was slight technical problem, so let us start today's class here. Hello dear friends, welcome to BYJU'S Exam Prep, and we are learning the time complexity problems under this how to start algorithms course. Okay, so let me continue with these problems which we done or which we stopped yesterday. Okay, so this is about me. Hope you all know about me, right? Now let me start with the problems here. Hi, good evening Tushar Sisodia. Hello. Yeah, let us solve this problem. Yesterday I given this problem. So let me continue from here, my dear friends. Now if you observe, the value of x is 0. Actually here loop variable depends on some n. N is not given. Okay, maybe it is given in the initialization part. Okay, so you can say n is also equal to 0 or something. Okay, right. Now how many times the outermost loop iterates? How many times? Yeah, Manishankar Tiwari, good evening, very good evening sir. Okay, so how many times the outer loop iterates? By rule 1, the outer loop iterates n times. By rule 1. Now by rule 2, rule 1 or rule 2 for the innermost, second loop. For the second loop, same rule 1 we can apply because j varying from 1 to n in steps of constants. Just by adding constant you are incrementing the value of j sir. So even by rule 1 it is also iterates n times. Got it? Now what about this third loop? Yesterday I given this, I said I will start with this problem only. Hopefully you all tried it. Now again rule 1 only, but here there is a small variation. Instead of going up to n, you are going up to 2 power n. So instead of n, you get 2 power n because you are incrementing every time constant value only. Am I clear? Therefore, it iterates how many times? Whatever is this value, that many times it iterates 2 power n times. Please remember that. Hope you understand. Got it? Therefore, what is the time complexity of this code, my dear friends? Theta n into 2 power n. So that is theta n square into 2 power n. And that is the time complexity, my dear friends. Hope you all understand. Is the idea clear? Good. If you have any doubts, you can write. Okay, you can post your comments, sir. I'll be reading your comments. If you have any doubts, you can write your comments here. Yeah. Got it? Now, all of you noted? Next problem. What about this? Please solve this. So nested loops, independent again. Now if you observe the outermost loop, by rule 1 which I given, it is simply iterates how many times? N times. Now the second loop, even this iterates n times only. See, it actually looks similar to the previous problem. There is a slight variation. If you observe the innermost loop, it is under rule 2. So here it is like for k is equal to 1, k less than or equal to this value is important, 2 power n, and you are incrementing the value of k. How sir? Every time you are multiplying by 2. Every time you are multiplying by 2, my dear friends. 2 into k. So now actually if you observe it is under rule 2. See, normally if it is n, it iterates log n times you write it. But instead of n, what is here? 2 power n. So just replace this with 2 power n. So this will take log 2 power n times. So how many times it iterates? Log 2 power n times, my dear friends. But log 2 power n is nothing but n into log 2. Log 2 is a constant, so this is approximately n times only. So the time complexity of this code, okay, is n into n, which is theta n cube. Hope all of you are able to follow. Okay. If you have any doubts, please do ask me, sir. Yeah. My voice and video are clear. Any problem? with the voice or the video, please let me know, sir. Is the problem clear? See, my dear friends, once you understand a rule, just need to properly apply things. Okay? Then you can solve any problem very easily. For example, our first rule says, for I is equal to 1, I less than or equal to n, I is equal to I plus 1 if you are having. This loop iterates n times. That is what we learned. Not only I plus 1, even I plus c also it is n times. Because we can ignore the lower order terms or we can drop the lower order terms and ignore the coefficient of highest order term. Now what type of twist and turns they can give you? They can change this value. For example, I may have the problem like I is equal to 1, I less than or equal to n into n, I is equal to I plus c. See, generally when you see this, people only see one part of the rule, not complete rule, they read it. So then simply they say n times because they are eager to answer the questions. But here it is going up to n square. So this is not n, it is n square. So rule you have to read carefully. Rule you have to read carefully. Sometimes it may be given like I is equal to n by 2, I less than or equal to n, I is equal to I plus c. Now in this case it is n by 2, even though it is n by 2 you are adding plus c plus c plus c and you have to read n. So instead of n, half of the times it will iterate. It will iterate n by 2 times approximately. See, approximately. See, n by 2 or n hardly matters. Asymptotically the coefficient of highest order term does not matter. So even this you can write n times, my dear friends. So this we need to understand. Sir, today I have come your class. I will finish today total videos. Great knowledge, sir. I have seen your videos playlist. Thank you Prashant Kumar. Okay, please do watch and keep posting your comments. Okay, I am here to guide you. If you have any doubts, okay, you can reach me out, sir. Okay, I'll give you my telegram ID. Okay, and I'll be connecting with you regularly, my dear friends. Thank you Prashant. And sir, repeat कर दीजिएगा. कौन सा रिपीट करना है माय डियर फ्रेंड? कौन सा तुषार? कौन सा प्रॉब्लम रिपीट करना है? तुषार भाई, तुषार कौन सा प्रॉब्लम रिपीट करना है? ये प्रॉब्लम रिपीट करना है या ये रूल रिपीट करना है? देखो सिंपल रूल्स 3 दिया था मैंने. पहला रूल ये है, I लेस देन और इक्वल टू n, I इज इक्वल टू I प्लस c. ये +2 होने दो, +3 होने दो, +4 होने दो, +100 होने दो, +10,000 होने दो, it does not matter. Asymptotically it iterates n times. Now what you need to understand is what is this and what is this. You have to keep track of this every time. Sometimes they may trouble you with these values. Instead of n they may give you 2 power n. So instead of n, suppose ये n के जगह अगर मैंने 2 power n दे दिया तो क्या होगा? 2 power n दे दिया तो क्या होगा? कुछ नहीं होगा, ये n के जगह 2 power n आ जाएगा बस. In the place of n you get 2 power n. Time complexity. Yes sir, I am discussing the same thing for you. I am repeating the rule also. Now the second rule कौन सा बताया था मैंने आपको? I is equal to 1, I less than or equal to n, I is equal to I into 2 बता दो, 3, 4, any constant. It will iterate log n times. It will iterate n times. So if it is c, it is log n to the base c, sir. But sometimes to confuse you, they give you the same rule with small twists and turns. For example, it may be asked like instead of n, they may give you n square. And they'll ask you I is equal to I into c. So क्या होगा इधर? ये n के जगह क्या है? n square है. Simple substitutional instances we call it. So log क्या होगा ये? What happens to this? Log ये n के जगह क्या है? n square to the base c आ जाएगा. समझ में आया है? Quick sir. After class, please tell me how to study below 100 rank. Please, this is my request. For sure, sir. See, getting rank below 500 is a regular study. Am I clear? From 500 to 1, it depends on your motivation and it depends on your hard work. Nothing can replace these two things, sir. up to 500 or 500 to 1000, it's a general procedure. Anyone who regularly understand all the concepts and apply, they can get it. 500 to 1 जो होता है, because even there the marks difference will be very slight variation, so you have to be very careful with that, sir. Okay? जी सर, समझ में आया तुषार? समझ में आया सब, वेरी गुड. अभी और एक थर्ड रूल भी दिया था मैंने आपको, लाइक i इज इक्वल टू इधर 2 या 3 या कांस्टेंट कुछ भी होगा, i लेस देन और इक्वल टू n होगा, और i इज इक्वल टू i पावर c होगा. ये पावर c होगा, पावर 2, पावर एनी पावर कांस्टेंट, ये कोई भी कांस्टेंट रहने दो, कोई दिक्कत नहीं. फॉर दिस आई गिवन log n. ये c है तो इधर c आ जाएगा, ये 2 है तो इधर 2 आ जाएगा. Now here also they may give you small variations, my dear friends. And for these 3 rules, I given the reverse rules also. You just go through that. I given derivation in time complexity part 1. I given derivations also. Am I clear? Okay, wonderful, wonderful, Prashant. Very good, good. Now let us see next problem. What is the time complexity of this code? अभी इसमें थोड़ा twist and turns है. It's not fair problem in direct problem. थोड़ा twist and turns है. देखो, फर्स्ट लूप रूल 1 के हिसाब से डायरेक्ट है n टाइम्स, रूल 1 से हो जाएगा, इट इज डायरेक्टली विथ रूल 1. वेयर सेकंड वन आल्सो रूल 2, बिकॉज 2 into j and you are reaching only n, so it is log n टाइम्स. ये भी सिंपल है. अब इंटरेस्टिंग है ये वाला, अभी आपको बताया था मैंने. देखो, थर्ड पार्ट आई एम राइटिंग सेपरेटली. k इज इक्वल टू 1, k लेस देन और इक्वल टू 2 पावर n एंड k इज इक्वल टू 2 into k. See, normally if it is 2 into k and you are reaching this fellow, whatever that fellow is there, log of that fellow, because base 2 na, log to the base 2, whatever is here that will come. But what is here? In this case it is n, but here it is 2 power n, so it is log 2 power n. So it will take log 2 power n times, my dear friends, log 2 power n times log 2 power n iterations, approximately, asymptotically. Okay, here we are talking about abstraction. Okay, we are not worried about exact answer. Lower order terms we directly ignore it because they will not contribute much, their effect is negligible. Higher order terms coefficient is ignored because that is machine independent. That's machine dependent, not independent, machine dependent. So these two things you should always remember. Lower order terms क्यों निकालते हैं? Because their effect is negligible. Higher order term का coefficient क्यों निकाल देते हैं? वो machine dependent है, इसलिए दोनों इग्नोर करके only the higher order term हम रखते हैं. समझ में आया है? Hope you understand. Good sir. Now ये आंसर हो गया है इसका. So what is answer for this? Theta n into log n into, so this is log 2 power n को भी हम थोड़ा सिंप्लीफाई कर सकते हैं ना. log 2 power n क्या होगा? What is log 2 power n? n log 2 हो जाएगा, which is approximately n, that is n. So which is theta n square log n, my dear friends. Wonderful. कोई दिक्कत, कोई डाउट, प्लीज आस्क मी सर. If you have any doubts, please do ask me. Please do ask me. मंडल, के लूप समझ में नहीं आया है, एक बार फिर से बता दूंगा, डोंट वरी. ओके, के लूप. See, K loop is same as this our regular one only, sir. One second, I do one thing for you. For you, let me take one blank slide and explain. See, my dear friend, Mandal, ये जो है ना, K is equal to 1, K less than or equal to n, K is equal to K into, ये 2 होने दो, 3 होने दो, कोई भी C होने दो. This will iterate log, not log base 2, sir. This will iterate log n to the base c times. This will iterate log n to the base c times. Now अगर इस n के जगह if I put something else, if I put n के जगह if I put n square, क्या होगा? What happens? How many times it will iterate? जो n है वो n square बन गया है, राजू बन गया जेंटलमैन. सो क्या करेंगे हम? log n स्क्वायर टू द बेस c करेंगे. यदि इफ इन द प्लेस ऑफ n स्क्वायर अगर मैंने 2 पावर n रख दिया है तो क्या होगा? What happens? That is what I am saying. Is that clear, Mandal? Is that clear? Please let me know. If it is clear, please let me know. Log n square. That's good. Wonderful. You understand? Am I clear? आपको समझ में आ गया है. बस इतना ही. Nothing more than that. Nothing more than that. Perfect. और इधर क्या होगा? log 2 power n के सिचुएशन में क्या होगा? नेक्स्ट वन ऑल्सो यू कैन आंसर. नाउ यू कैन आंसर. ये भी आंसर कर दो अभी. यू कैन आंसर दिस वन ऑल्सो. एवरीथिंग सेम वे. सी इट इज सिंपल मैथमेटिक्स. देयर इज नो रॉकेट साइंस इन दिस. कंप्यूटर साइंस है, रॉकेट साइंस नहीं है. सिंपल है. बट वी कैन मैनेज रॉकेट्स विथ आवर कंप्यूटर साइंस. प्लीज रिमेंबर दैट. ओके, क्लियर? Is this all or nested loops? In real life, best algorithm we need means best program is yes, sir. See, it's not necessarily, because it depends on the type of program, my dear friends. Always see the time complexity. Why we require time complexity, sir? We always, aim for linear time complexity. Not even, polynomial time complexity. See, if it is exponential, at least we try to reduce to polynomial. If it is polynomial, then we are very much worried about linear time. Am I clear? See, that is the basic idea, my dear friends. Nothing more than that. So this would be log. Okay. ये क्या होगा? log 2 power n to the base c, which is n log 2 to the base c. And ये जो है 2 log n ही होगा. इधर ये log n times होगा, but it is ये constant है तो ये n times होगा. So that is the idea, my dear friends. Hope Mandal, I cleared your doubt. Mandal, I cleared your doubt? Yes? Super, super. The next problem. अब third variation भी आ गया इधर. Third rule. ये देखो, third rule. Hope you remember this rule which I given, or if you not remember, this is the rule which I given. Okay, otherwise let me write it in the blanks again. Now let me explain this rule. For those who you missed the previous one, because without understanding the rule you cannot solve the problems. Please remember, this is the rule. I is equal to 2, I less than or equal to n, I is equal to I power c, कोई भी constant. और दूसरा इसका रिवर्स वाला, I is equal to n, I greater than or equal to 2, I is equal to cth root of I. For both the fellows, reverse direction और फ्रंट डायरेक्शन. ओके, सी पावर सी करेंगे, रिवर्स में क्या करेंगे? सी रूट करेंगे, बस. सो हियर व्हाट हैपेंस? फॉर दिस द कॉम्प्लेक्सिटी वुड बी log n होगा, इधर बेस सी होगा, दिस सी, एंड इधर बेस 2 होगा. इवन फॉर दिस सेम स्टोरी, log n to the base c, and it is 2, sir. But asymptotically this can be simply written as log n, my dear friends, because base of log does not matter. ये हमेशा याद रखना है. Base of logarithm does not matter. Okay, hardly. But power of exponent or base of exponent matter करता है, because 2 power n करेंगे, 3 power n करेंगे तो वेरिएशन हो जाएगा. But base of logarithm, whether it is log n to the base 2, log n to the base 3, asymptotically it does not matter, my dear friends. Its affect only a constant factor. Am I clear? Very good. So now we understand this. Now let us solve this problem. So what is the first one? Outer loop. Because they are independent, directly I am writing. Otherwise we need to start from inner to outer generally. So here I apply rule 3. Just now I explained the rule 3. So according to rule 3, see whether it is 2 or 3 does not matter, sir. According to rule 3, because n to 3 you are going, and every time you are taking cubed root of I. So the answer for this is log n. This is 3, therefore here base is 3. This is 3, therefore here base is 3. But as I told you, the base of logarithm hardly matters. Even if you write asymptotically this as log n, there is nothing wrong, my dear friends. There is nothing wrong. Hope you understand. All of you able to follow? Yes or no? Got it? Yeah. Got it. Next problem. Now this is interesting problem. I want someone to answer this question, sir. Very good, Tushar. Very good. Wonderful. Simple 3 rules का खेल रहे थे 3 दिन से हम. Okay? We started with linear loops, then we introduced the nested loops. बस उसी को इधर उधर करना है बस. Okay? And that is what even in GATE. Today I will take up some more interesting problems. How they twist and turn problems. That also we try to understand. Okay? पहले ये समझ में आ गए तो automatically you understand the rest of the story, my dear friends. Okay? Next, anyone answering this? Anyone answering this? What is the answer for this interesting problem? See, now someone is asking about mathematical importance. Now the entire data science is based on, your linear algebra, what you are doing. Linear algebra is having its application in many fields, my dear friends. Okay, you can apply it in vector spaces, you can apply in data science. The big data you can handle using matrices. Am I clear? So everything, even if you take differential equations, okay, almost anywhere, wherever, see, derivative you talk it now, whenever there is a change, that change phenomena can be applied, or that change phenomena can be understood with a differential equation. So every topic, see, probabilistic analysis, okay, probabilistic, you can expect how many members can qualify this year GATE. Even this from the previous statistics we can say that, on effect of rain or all this kind of any predictions can be done. Now it is the era of artificial intelligence, and for that the predictions are very, very important. Okay, you can say some, even in when you are buying Amazon, some you buy something, immediately they show you related articles. Okay, all these are all based on artificial intelligence, machine learning. Okay, they learn based on your previous buyings. They'll give you the choices, you can buy this based on your choice. Clearly it will be mentioned in that. They are all real life applications only. Okay, they are not derived from something else. They are all derived from all these basic mathematical concepts only. So mathematical concepts are used everywhere. Okay, and you see algorithms, the entire algorithms is based on simple mathematics. It's not even calculus, sir. It is simple arithmetics, algebra. We are doing algebra only here now. Correct or not? Either algebra ke alawa, are you doing any calculus part? Maybe for theta notation I explain little limit notation only. To understand which one is larger, which one is smaller, which one dominates which, we use the limiting concept. To understand that, limiting concepts are used asymptotically. For large values of n, whenever, see, large values of n, limiting behavior, long run behavior, we need limits. Without limit, kya hoga? How can you estimate or how can you identify the long run behavior of a function? See, if your input is a very large fellow, without knowing how it behaves, you cannot directly write code and run. It may take years of time. Am I clear? Like that. Yeah, log n. See, now look here, the outermost loop. N, every time you are reducing it by n by 2. See, you start with n, every time you are reducing it by n by 2. So, n minus n by 2 is n by 2. Again, next time you reduce it by n by 2, it becomes 0, because it is not greater than or equal to 1, you come out of the loop. So, it takes only 3 iterations. See, third iteration you come out of the loop, sir. So it is constant, sir. See, here it is not depending on the rule. So don't think that every time you apply rule only. You have to be careful. You have to see this initialization, the condition and the increment, everything you have to see carefully. They may twist problem here. Now second loop. Second loop if you observe, see as I told you our rule is what sir? Simple rule. कौन सा है हमारा rule? J is equal to 1, J less than or equal to n, J is equal to J into constant, कोई भी constant. It will iterate log n times to the base C. If it is C, base C. But here it is 5, so base 5 हो जाएगा. And what is this n place? What is the term at n place? n square है. So ये क्या होगा? Log n square to the base 5 हो जाएगा. Nothing more than that. Good, Tushar. Yeah, wonderful. Nothing more than that. Simple. अब ये क्या है? This is reverse of our rule. देखो, this rule we can write in the reverse order. J is equal to n से लेकर J greater than or equal to 1, but every time you are dividing by constant. J is equal to J by C. Then this will iterate how many times, sir? Then this will iterate log n to the base C times. Okay, let me write base C, no? Log n to the base C times. Here also. Now in this case you see you are not starting from n, you are starting from n power 5. So इन्होंने ट्विस्ट इधर दिया था, कहानी में ट्विस्ट इधर है. सो क्या होगा? इंस्टेड ऑफ ये n है तो n आएगा, n पावर 5 है तो ये क्या आएगा? log n पावर 5 to the base. What is base here? 2 to the base 2. The base of logarithm does not matter, sir. So what is the time complexity? Time complexity of this is, ये constant है. 1 you can write, sir. Constant means you can write 1 also. When you are multiplying na, you write C, you write 1, does not matter. Anyhow, the constants will be ignored later on. 1 होगा. और next log n square. See this log n square can be written as, actually it is equal to only, it is equal to 2 log n. Base कितना भी होने दो. So what is it? It is approximately log n only. And what about this log n power 5? ये होगा 5 log n to the base 2. कोफिशिएंट इग्नोर कर दो, ये भी log n to the base 2 हो जाएगा. यानी सेकंड वन log n ही है, थर्ड वन इज ऑल्सो log n. आ गया DV AB, वंडरफुल, सुपर. सो व्हाट हैपेंस? थीटा भूल गए हम. थीटा log n होल स्क्वायर, या तो log स्क्वायर n भी लिख सकते. ओके, प्लीज रिमेंबर दिस. Yeah, you can Monday class also you can join, but today I had some topic to complete. Up to that I'll complete it and I'll cover it, okay? Because this part I am going in a very slow manner so that everyone can understand. This is not difficult. Generally people feel difficult, they do some rules and all other things to complicate this. It's not complicated. I am just trying to see. People misunderstand these ideas, simple ideas. If you can properly understand it, you never do mistakes in your life. Please remember. नेक्स्ट वन. अब मैं डिपेंडेंट लूप के ओर जा रहा हूं. आई एम अबाउट टू गो. हाय सर, गुड इवनिंग. नो प्रॉब्लम सर. बेटर लेट देन नेवर. ओके, बेटर लेट देन नेवर. गॉट इट. अब क्या होगा इसका हालत? व्हाट हैपेंस टू दिस? नाउ लुक हियर, आउटर लूप तो डायरेक्ट है n टाइम्स, बट नाउ द सेकंड लूप, सी केयरफुली. सेकंड लूप क्या हो रहा है? आई एम राइटिंग इट अगेन. Sorry, कहीं और चल गए. J is equal to n by 3, J less than or equal to 2n, and J every time what is that you are adding? N by 3 you are adding. So J कहाँ से शुरू होता है? From where it starts? N by 3. Every time you are adding n by 3. So n by 3 plus n by 3, which is 2n by 3. Okay, this is 2n by 3. Hope you understand. Next, again n by 3 plus, that is 2n by 3. Again you add n by 3, it becomes n. Now n by 3 means what, sir? To reach n it takes 3 steps. So n by 3 to n, here 2 steps and there 3 steps. Total 5 steps you are going to take to reach 2n, my dear friends. To reach 2n, 5 steps you take, but equal to 2n also you enter the loop. So 6th step you come out of the loop. So total iterations it will take is 6 iterations. Whatever it is a constant, my dear friends. See, I just see it as a constant. For me, 6, 7, 8 does not matter. Hardly how many iterations? 5 iterations, it enters the loop. 6th iteration, it becomes 2n plus n by 3, it will come out of the loop. So what is it? So the time complexity for this is theta n into constant, or simply theta n, my dear friends. Wonderful. B, super. Theta n, wonderful AB, Rocky. Hope you understand. If you have any doubt, yeah. Hi Das, Himagna Das, very good. Tushar, wonderful, rocking, sir. You are all rocking. Great working. That's it. See, once you understand these rules, whatever problem comes, whether it is GATE or any type of examination, you just answer that like this, just like that. Just you need to understand how the things are moving. Just identify what is the initialization, what is the condition, what is the increment. See carefully. And if it falls in any of our rule category, apply it. Otherwise, carefully solve it like this. That's it. Am I clear? Clear. Wonderful, Tushar. Now this is a very interesting problem, sir. This one is a very interesting problem. Okay? So please try. What is the answer for this? I want your answer before I start doing it. I want your answer, my dear friends. I am waiting for your answer. Sorry. C. Wonderful, Himagna Das, you are answering very quickly. Good. But see carefully. Let me tell you, अभी बताया था मैंने आपको एक बात. Initialization, condition, increment. Increment is I is equal to I plus X. यानी जो X value अपडेट हो रहा है वो इधर यूज कर रहे हैं. We are using that X value. तुषार सी, हाँ बताया था ना, ये थोड़ा ट्विस्टेड प्रॉब्लम है. ट्राई टू अंडरस्टैंड. लेट अस सी दिस प्रॉब्लम केयरफुली. ओके, हम इस प्रॉब्लम को थोड़ा केयरफुली समझें. x 0 है. फॉर I is equal to 1, I less than or equal to n, I is equal to I plus x, where x is incremented every time. हाँ, डिविलियर्स गिवन गुड आंसर. तुषार सिसोदिया भी करेक्ट आंसर दे दिया है. सो लेट अस सी दिस. इसमें क्या हो रहा है, पहले व्हेन I is equal to 1, ओके, I is equal to 1, x वैल्यू क्या होगा, 1 हो जाएगा. नाउ x is added to I, so now I value which is originally 1, what is added to I, ये x वैल्यू ऐड कर दिए हैं. तब अब x वैल्यू क्या होगा, because x value क्या होगा, see x value every time is just incremented by 1, that's it. So x value 2 ही होगा, but that 2 is added to current value of I. What is current value of I, sir? 1 plus 1 plus current value of I is 1 plus 1, whatever. Okay, if you want you can write 2, sir, but I want the pattern so that I can simplify it easily. So 2 will be added to this. अब x value क्या होगा, 3 होगा. Now to the current value of I, which is 1 plus 1 plus 2, ये 3 add हो जाएगा. This 3 will be added. Okay? Now x value क्या होगा, 4 होगा. Now you need to tell me how long you continue this story. See, you have to continue the story till this condition is satisfied. यानी ये जो I का value जो आ रहा है, like 1 plus 1 plus 2 plus 3 plus and so on, till this value equal to n or less than n, you continue. So I am taking equal to n for simplicity. So it has to become n. But when it will become n? Because you are adding 2, you are adding 3. See, it's not directly I becoming n, sir, because 1 plus 1 plus 2 plus 3 plus and so on, maybe when you add plus k, it may become n. Maybe when you add plus k, it become 1. So it is like 1 plus, what is sum of first k natural numbers? k into k plus 1 by 2, my dear friends. And till this happens, the loop iterates. And you need to know what is that k. K tells you the number of iterations. Because this, how many times it is iterating? See, third time you are adding 3, second time you are adding 2, kth time you are adding k. So you have to find k value. K will tell you number of iterations. K will tell you number of iterations. Wonderful, AB, wonderful. So you simplify this. Of course, you can write the detailed expansion of quadratic equation. You can solve it. Okay, you all know, right? This ax square plus bx plus c आएगा. This you can solve it, sir. Is equal to 0 करके x is equal to minus b plus minus root b square minus 4ac by 2a करके भी solve कर सकते हैं. But we do approximation because left hand side is of order k square and right hand side is n. Then what is the value of k, sir? Root n. So this is how we simply solve it. If you want, you can completely convert into quadratic and use this, can get the value of k, sir. Like that also you can do it. Okay? But instead of that, directly by observation you can do it, sir. This is important. Yes, yes. K square is equal to n approximately. It's not exactly, approximately. Therefore, k is equal to root n. So what is the time complexity for this, my dear friends? The time complexity for this is theta root n, my dear friends. Theta root n. Is the idea clear? All of you able to follow? That's it. So, see, generally what happens for such problem, people try to remember it as a rule, but don't do it, sir. See, of course you can remember it as a rule, there is nothing wrong, but how many you remember like that? So, pattern you understand. Pattern you need to understand for this. Okay? वो pattern समझने की कोशिश करो. Of course, there are few exceptional problems like this for which people try to remember them as a rule. Okay? But this is good. I like AB doing it perfectly. Good. Great, sir. Great. Tushar. Wonderful. Okay. Now, sometimes instead of asking time complexity of the code, they can ask you what is the value of the k. But return value of k exactly is not asking. Return value of k you need to tell in terms of asymptotic notation. Here in this problem you have to say the return value of k, not the time complexity of the code. Return value of k. Time complexity of code is different for this problem. Return value of k is different, and the question is return value of k, my dear friends. Return value of k. Hi Arunva Chaudhary. Hi sir. Got it, Himagna. Very good, very good. Like it. Wonderful, wonderful, sir. You people are rocking. Now look at this. How we solve this problem. Okay. Now I just taken the same code here. I written. We need to find the return value of k. If anyone want to answer, can answer, sir, this question. This is a gate question only. I not written. It's a gate question. See, some of the problems which I given are all gate questions only. I just modified for my purpose so that I can explain the rule properly. I just modified those questions. Most of them are gate and different variants, my dear friends. Okay? All the variants are taken into consideration. What is the return value of k? Anyone want to answer this? Hi sir, welcome to all of you. Welcome all. Yeah. Any suggestions? Now let me explain this problem in a simple nutshell. If you observe, we need to tell what is the return value. What is written, sir? K is written. We need to find return value. Return value in asymptotic notation we have to give. And return value is what, sir? K. So we have to say k value asymptotically. C. Okay, Tushar says C is the answer. Let us see. Hi Kannababu, today you are late to the class. Right. Good. N square log n. Wonderful, Chaudhary. Arunava Chaudhary. Wonderful. Wonderful, sir. Very good. Great. Dekhe, if you observe this is a very simple problem. Here, every time the value of k is incremented by n by 2. For each iteration, the value of k is incremented by what? N by 2. सो कितने आइट्रेशंस होता है उतने बार n/2 ऐड करेंगे. हाउ मेनी आइट्रेशंस हैपेंस दैट मेनी टाइम्स यू ऐड n/2 माय डियर फ्रेंड्स. नाउ यू जस्ट नीड टू टेल मी हाउ मेनी आइट्रेशंस हैपेंस. जस्ट सी दिस लूप. For I is equal to n/2 to I less than or equal to n I plus plus. So this one will be n/2 times, because n/2 to n means n/2 times, and inner loop j is equal to 2 to n in multiples of 2, that will take log n times. Okay, again why should I write this, sir? Hope you can see this. No, directly I write it from here. Why to write again? Okay, this is here. No, anyhow, I'll directly use this. Let me clear this. I'll just write this. It will take n/2 times, means I am counting number of iteration. I am counting number of iterations, and it will take log n times. So now I know the number of iterations. मुझे number of iterations पता चल गया है. n/2 into log n. Because asymptotically now you can just write n/2 into log n. n/2 into log n. Wonderful, wonderful. All of you are rocking, sir. B, 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 A, B. सब लोग B बोल रहे हैं. Let us see that. Now this is number of iterations. See, for each iteration, see k value initially क्या था? K value initially is 0. For each iterations you add n/2. Second iteration you add n/2. Third iteration you add n/2. How many times you add n/2, sir? How many iterations are there? How many iterations are there? That many times you add n/2. This is equal to how many times? n/2 log n times. So n/2 is added to itself n/2 log n times. Therefore, it is equal to n/2 into n/2 log n, which is nothing but n square by 4 log n. If you want to write it in asymptotic notation, theta n square log n, my dear friends. Theta n square log n. Tushar, wonderful, great. That's it. Theta n square log n. B is the perfect answer. Great, sir, great. All of you are rocking. Wonderful, great, super. अगर कोई दिक्कत है, any doubt, please do ask me, sir. Now I am moving on to the dependent nested for loops. Okay, one important idea, one general problems we do. One important idea I'll tell you that we can close. 3-4 problems we do it, but generally it will it can help you in solving almost all problems, sir. Am I clear? That way I tried. Let us try that. The dependent nested loops. Dependent nested loops. What is the complexity of the following C code segment? Now here, I value varying from 1 to 1 in steps of 1, but J value varying from 1 to I. So J depends on the value of I. So we call them as dependent loops. That is, the inner loop variable depends on outer loop variable. Please send me 27. See, I'll give you my, what do you call this? Telegram channel link. I'll try to upload all my PDFs in this. Okay, maybe in short time. Okay, please log into this. PLA. So this is my Telegram ID. You can log into it. Okay. There I'll give you these details, my dear friends. You can. There I'll send you this class PDF. Today's class PDF I'll send you. Waiting for complex topics. See, there is nothing like complex. If you feel complex, it is complex. So please tell me what is the complex topic. I did not able to understand dependent loops. See, dependent loop, let me tell you once again, AB. See, my dear friends, if you see the previous example, the value of I varies from 1 to some value, and J value also varies from 1 to some value independent of I value. Here if you see, the J value varies up to what? Varies up to I. That is, if I is equal to 1, J varies up to 1. I is equal to 2, J varies up to 2. I is equal to 3, J varies up to 3. Is the value of J inner loop variable depending on outer loop variable or not? Okay. Yes, I will be teaching in everywhere, my dear friends. I am here for all the batches or all variants which are available under BYJU'S Exam Prep. Recorded is completed, YouTube, free app classes, paid classes. Okay, from tomorrow I am starting, mathematics batch. Every weekend there is, for paid batch, there is 4 hours classes there. Okay, that I will be taking. See, they are going according to schedules, my dear friends. Okay, schedules are not under my control. So whenever my class is scheduled, I will be taking it. All subjects which I am expert, okay, that will be taken by me at some or the other time, my dear friends. Good. Right, wonderful. Hope you understand. That is the idea. Now let me tell you how you solve this problem. Please understand, this is the procedure, method. Let us understand the method for this. Let us understand the method. Now if you see outer loop variable, you use a sigma notation. Outer loop variable varies from where to where, sir? 1 to n. For each of these, the inner loop variable, j varies from where to where? 1 to, कहाँ तक जा रहा है? I only. See, my dear friends, for individual topic courses are there or not, we do not know. But even Anil Prasad sir and Satya sir, the other faculty members, they are all taking some classes online. Okay. See, generally in online, the important topics will be covered, but it's not possible to cover them in a systematic order. Maybe sometimes you may start some crash course. See, the ultimate idea is to help the students, but there's a big system where we have to run, so many things. So obviously there is one channel where the paid classes are in a more, detailed manner. Okay, here we'll be coming up with whatever topic I am taking. I am trying to see that you will understand that topic perfect. And every faculty will do the same, my dear friends. Okay, let it be Anil Prasad sir, Murali Krishna sir, Satya sir, whoever it is. They are all taking. I am talking about computer science, my dear friends. We have so many other faculties. Okay, now the faculty pool is very good pool we are having. So everyone is trying to give their best to reach you out. Okay, it's all, our aim is to reach more and more people, to help more and more people, my dear friends. Thank you. Okay, yeah. Now you understand, j varies from 1 to n. And here code, it may be one statement, 2 statement. So constant I am taking simply 1, sir. For simplicity I am taking 1. If it is 2 or 10 also, that can be taken outside. Now if you observe this is what we have to simplify. Sigma I is equal to 1 to n. See, my dear friends, whenever you are going from a lower bound to upper bound, the number of terms is given by upper bound minus lower bound plus 1. So here you are going from 1 to I. So here this 1 is added to itself how many times, sir? Upper bound minus lower bound plus 1 times. So here upper bound is what? I, minus lower bound is 1 plus 1 times. So these two get cancelled, which is sigma I is equal to 1 to n I. Now you just need to solve. Yeah, I am doing 28 only, Kana Babu. I am doing 28 only. I am doing 28 only. Okay, see this carefully. I quickly repeat it. See this carefully. ये I 1 to n जा रहा है, समेशन में I वैल्यू 1 to n जाएगा. ओके ना? Here j, from where to where j is going, sir? J going from 1 to I, so the second variable going from 1 to I. That's it. And this summation, how you get it, sir? Any summation when you are having a constant inside, upper bound minus lower bound plus 1. Upper bound is I minus lower bound is 1 plus 1. Am I clear? I times. Correct. Now you just need to do this. So here 1 to n, I varies from 1 to n. So I is equal to 1, I is equal to 2 and so on up to n. And which is sum of first n natural numbers. Yes, maths paid batch is starting from tomorrow at 6 p.m. 6 to 8, then 8:30 to 10:30, that maths class. I am starting mathematics also on paid classes, my dear friends. Okay. Now what is it? Sum of first n natural numbers, n into n plus 1 by 2. So number of times this loop iterates is given by n into n plus 1 by 2, which is nothing but 1 by 2 n square plus 1 by 2 n. Now we can drop lower order terms and ignore the coefficient of highest order terms. Therefore, the time complexity of this is theta n square, my dear friends. Wonderful. That's it. Simple है. But इतना summation every time करने की जरूरत नहीं है. We don't have to do this much summation every time. For this, there is a simple trick which I'll tell you now. Okay? But you have to be careful, sir. See, here I am able to write. See, if you do the summation, you can confidently say theta n square. But now I am going to give you a trick. With that, you can give big O notation. Upper bound दे सकते हो. Theta you have to verify. Verification के बाद theta हुआ तो theta, big O हुआ तो big O से दे सकते हो. But for that you have to verify, my dear friends. से verify करना होगा. Okay? Wonderful, sir. Now this is the trick which I am talking about. You can call it as a trick or note, whatever. In general, when the upper bound of loop variable depends on some other variable, we consider the largest value of the bound. That's what I am saying, sir. That's what I am saying, my dear friends. See, Kanna Babu, you can same 28 I am doing, sir, shortcut. For you I am giving shortcut. See, it's simple rule, sir. Logical idea. We can take it as a trick. See, my dear friends, here outer variable is I, and what is the upper bound? Maximum value of I kitna hai? Upper bound of I. You can say max value of I or upper bound. Upper bound of I. N. Now this J depends on this I. When J depends on I, so for this you can take N. Obviously I varies from 1 to N, so I varies N times. Now because J is depending on I, the trick is, because J is depending on I, the trick is we can take the upper bound of I as J maximum value. The number of times it iterates. What is upper bound of I? N. So we take order n times. That is the idea, my dear friends. N. That's it. You use that upper bound. Therefore, the time complexity of this is big O. Because here we are just using an upper bound. We are not using tight bound. Because J varies up to I. For I taken the upper bound, which is N. So can you say theta? You cannot say. If you want to say theta, you have to do the summation. But if you want to just say the answer, you can say big O of n square. But because it is proved, you can write theta n square. But the idea is this one. Big O of n into n, which is n square. Big O of n square. Dekho, Kanna Babu, you just solved it within no time. J goes up to I, and what is the highest value of I? N. So for this also you take n. Done. Got it? So this is the simple trick for this, my dear friends. So whenever this dependent loop comes, generally people don't solve it. They just use what is the upper bound for this, what is the upper bound for this, what is the upper bound for this. They solve it. That's it. See, for example, if I am having a problem like I is equal to 1, I less than or equal to n, I plus plus, okay, and for j is equal to 1, j less than or equal to I, j plus plus, for k is equal to 1, k less than or equal to j, k plus plus. What is the answer for this? What is the answer for this? What is the answer for this? Please tell me answer for this. Wonderful. See, algorithms is all about asymptotic notation and recurrences. Those who understand these ideas properly, 70% sorry 70% of algorithms is done, sir. Because divide and conquer based on recurrence, dynamic programming is based on recurrence. Okay, even greedy, internally it is recurrence only, but we generally don't use it. Am I clear? N cube, 100, wonderful, Himandaras. Wonderful, great, sir. Same, here it is n, and for j what is the upper bound? I maximum value is n, therefore it is n. And for k, j is the upper bound, and j ka maximum value, because j varies maximum up to I, so we take the upper bound of I only for k also. This is n, so it is big O of n cube. This is the trick which generally people follow, sir. Great, great, great. Okay. Wonderful, Kanababu, you are rocking. Tushar, great. AB de Villiers, great. All of you are rocking, sir. That's it. Okay. Next problem. The next problem. What about this? Sir, Monday your which topic tells, sir? Please reply me. Ready to Monday class. Monday class solving recurrences. Recurrence solve करना सिखाऊंगा. Monday, Tuesday दोनों दिन we learn how to solve recurrences, recurrence relations, recurrence equations. We learn that. Monday we'll do that. How to solve recurrences. Monday and Tuesday. That is, Monday is I think today 24, 25, 26, 27th Monday. Same 8 p.m. sir. And 28th. Solving recurrences. Same story on both days. Got it? Wonderful. What about this? See, here j starts from I. See, generally it looks like same problem. See, when we solve so many problems, when you see, you may write n square. Here also j starts from I. So even here j depending on I, upper bound can be taken. Order n square you can happily write for this also. Whether you starting from I, ending at some value. See, ultimately you are ending at n. Ultimately you are ending at n. Some I value you are starting. So maximum of that is n only. So you can use same idea and you can write the answer for this. But if you want to use summation, see, this is very important, sir, learning summation notation. Let me explain the summation also. Generally people feel it is very difficult, sir. See, basic level problems you can solve like this, but advanced problems there are, okay. Of course, GATE they are not asking that much advanced questions also, but one should always know this idea. This will help you a lot. So here you see outer loop. I varies from 1 to n. Inner loop j varies from I to n. So number of statements constant only. Big wonderful, sir. You all rocked. You all know the answer. N cube. For this n cube, n square. No, n square. 29th. Please see, it is not n cube. I said na n square. Why you are writing n cube, sir? Huh? Chalo, dekhi. Now here you see. I is equal to 1 to n. See here, upper bound minus lower bound plus 1. Upper bound plus minus lower bound plus 1. Now, you can write it as sigma I is equal to 1 to n minus sigma I is equal to 1 to n I plus sigma I is equal to 1 to n 1. Here actually n is a constant, can be taken out. So you get sigma I is equal to 1 to n 1 only. So it is exactly same as this only, sir. So actually here sigma I is equal to 1 to n, 1 is common. So I can take n plus 1 common here. Instead of writing 2 times, for these two fellows, I can take n plus 1 common, constant common, sir. Minus sigma I, sum of first n natural numbers. Yes, sir, sigma is wonderful, Himantha, wonderful, Tushar. Tushar, you just correct it, sir. AB is correct. Okay, so let us write constant na bahar likhenge. We write it outside. n plus 1 होगा और ये sum of first n natural numbers. What is it? n into n plus 1 by 2. Okay, so if you simplify, I think, okay, I'll just keep it. Let me keep a blank slide here. Okay, so what is that you got? N plus 1 into sigma 1. Sigma 1, 1 second, sir, I'll just come back. Oh, sorry for that, my dear friends. Haven't turned off my camera's battery, so it was troubling you. Sorry for that, sir. Good, sir. Good, sir. Sorry for that. Now n plus 1 कहाँ थे हम? N plus 1 into n minus n into n plus 1 by 2. Taking n into n plus 1 by 2 common, or n into n plus 1 common, 1 minus half, which is nothing but half, which is n into n plus 1 by 2. See, now you can happily announce time complexity is theta n square. If you solve this, you can happily announce the complexity is theta n square, sir. Okay? Super. Yeah. Right, next problem. Great, sir. AB, wonderful, wonderful, great. Great. Yeah. Now the most important problem, sir. This is the most important variant, my dear friends. Most important variant. This is the most important variant, my dear friends. Theta n square. For the 30th problem, theta n square. Please check. What is the answer for this? See here, the bond is like j plus I, it is not j is equal to I. So you can say big O of n square, but this is important, I said. There is a small twist in the story, and remember this also. You can also remember it as a result, my dear friends. Whenever you get this partner, yeah, that you can write big O of n square, there is nothing wrong. But there is much tighter bond than that. That we try to understand. Okay? So you can remember this is one of the important variant. In GATE you can see this problem many times, my dear friend. The same, nested loop was given in GATE many times. So let us understand this. Can I ask first 5 minutes see, generally towards the end questions I am interested in than in the beginning. See, in the beginning people are interested in learning the concept. Towards the end, those who are interested to ask any doubt can ask. Okay, so today's class also, after the class you ask me anything, we can discuss. Okay, that would be better, no? See, because in the beginning of the class you will be asking something which may be a particular doubt for you, which may not be relevant to all other students. So towards the end that would be better. That is my suggestion, my dear friends. Now let us see this. Now look here. When I is equal to 1, j, see what is happening, j will be j plus 1. So you are incrementing by 1. See, actually, the inner loop every time depends on the value of, I, but how it is happening when I is equal to 1, it is like for j is equal to 1, j less than or equal to n, j plus 1. So this iterate n times. The inner loop iterates n times. When I is equal to 2, what happens? See, when I is equal to 2, the inner loop, I am just writing for this loop. From next loop onwards, we will write the generalization. J is equal to 1, j less than or equal to n, and j is equal to j plus 2, it will happen. Okay, so it is also n times only, but if you observe, this n times you have to write properly because it increments, j value increments like this. 1, 3, 5, 7, like that it has to reach n. When it will reach n, sir? Kth term. So what is the kth term, sir? 1 plus k minus 1 into 2 is equal to n. When you simplify, you get the value of k is equal to n plus 1 by 2. So approximately it will iterate n by 2 times, sir. See, if it is only this fellow, you can write n by 2 as n. But when you are having a series of fellows, one is n by 2, one is n by 3, in that case, that part cannot be ignored, my dear friends. That's why we are going to consider every time. So similarly, when I is equal to 3, it has to be approximately n by 3 times. Am I clear? 1, 4, 7 like that it will go, approximately some by 3 you are going to get. I am just taking that leading part, n by 3. The constant parts I am ignoring anyhow, lower order terms. Am I clear? Now when you continue this, when I is equal to n, it will go n by n times. This is very important formula. You can remember it as a formula. Whenever you get this nested for loop, now you can remember this answer, sir. What answer I am giving, you can remember it also. Okay? But if you understand the process, that is much better. Now if you observe, what is happening? For I is equal to 1, it iterates n times. For I is equal to 2, it iterates n by 2 times. I am writing time complexity, sir. Approximately. N by 2, n by 3, and it continues up to n by n, my dear friends. Now taking n common, it is 1 plus half plus 1 by 3 plus and so on 1 by n. And what is it? Harmonic series. And harmonic series, okay, the sum of first n terms can be approximated as log n to the base e. But base of logarithm does not matter. Therefore, this is n log n, my dear friends. And you can write theta notation for this. You can happily write theta notation for this. Therefore, Tn is equal to theta n log n. And that is the complexity, my dear friends. You can remember it as a formula also if you want. This is asked in GATE. Am I clear? As a part of a problem also. You can remember that. Wonderful. You can write theta of n log n also. There is nothing wrong. Theta also you can write. It is n log n times. See, combinedly, not separately. Combinedly, the effect is n log n. The combined effect is n log n. That you need to understand. Combined effect is n log n, sir. Hope you understand. All the problems are clear. Okay. So, on what you said, on Monday we start with solving recurrences, 2 classes. Okay, I will be coming up with the next schedule soon. Okay, you subscribe to the channel. Am I clear? So there is something called, all these people, famous YouTubers say, subscribe to my channel, press bell icon. If you do it, you will get notifications. Am I clear? And anyhow, on BYJU'S Exam Prep app, I will be available. On YouTube also, I will be available. And you can, join my Telegram channel. Am I clear? And if you want to send me WhatsApp messages, you can send me WhatsApp messages on this, my dear friends. I'll just give you the number 810-66-544-88. WhatsApp messages you can send me. Okay? See, I'll be replying. See, generally I am very rarely connect on the social media, but obviously when more people want to get advance or they get advantage of it, so definitely I'll help you, my dear friends. And you can also connect me over my Telegram channel for regular updates about my classes. Okay, I think I already given my Telegram channel, even I don't remember, sir. So t.me Sridhar DHULIPLA. Actually, PALA should be there. Can you give suggestions ending, sir? Waiting students. Yes, sir. Yeah. So this is suggestion time. Please ask me your doubts, sir. Now, please ask me your doubts. I am open for your suggestions or your doubts. Please ask me, sir. Very good, Himagna. Right. Great. So you can send me the WhatsApp messages. So whenever I see, I try to reply those WhatsApp messages. Okay. And mainly, if you join this Telegram channel, I will be giving my regular updates, my dear friends. Okay. Now you can ask your doubts, sir. What are your doubts? Last 5-10 minutes or more, whatever it is. Till what time you want me to ask, you can ask me. Today I am free, weekend, happy weekend. Yeah. The class is open for general doubts, my dear friends. Bye bye, very good night, Mr. A.B. de Villiers. Wonderful. Okay, you continue this method or this approach, my dear friend, A.B. de Villiers, you will definitely rock. Okay, you can definitely get a very good GATE rank. GATE 100 required, we study books or BYJU'S enough. See, my dear friends, when you join any coaching, okay, the basic idea of coaching is you can depend on the coaching because it is a supervised learning. They'll give you a systematic courses and the courses are conducted in a systematic order, and with that courses there will be workbook, practice problems, all the PYQ questions are solved. If any of the problems are not okay, there may be some mistakes here and there definitely happen. So you can approach faculty. See, during the classes here also, yeah, happy weekend. Here also you are asking me doubts. There the doubts you can directly connect. Here also you can connect to me. See, ultimately we want to help you people. Okay. See, definitely there is a system. In the system there is a sequence of there is a sequence for the course plan. There is a ordering for the books. Okay, there is a recorded content which is recorded with good efforts of many people, and of course there are live classes happening. Even we are trying to reach out, we want to help because the very idea of this online classes is to reach out more and more students. If you reach the same number of students when you are having offline classes, what is the use? Okay, see, everyone is capable of getting that 100 or 10, these are just numbers, sir. You enjoy your preparation. See, it is your travel with your subjects. It is your travel, your journey. If you do this journey properly, the ranks are just side effects of your journey, my dear friends. Am I clear? The rank is just a side effect. Your journey must be a happy journey. Just like happy weekend, happy journey. You enjoy every moment of it. See, now you say the 100 rank, so you are stressed. You want to put more stress on you. See, 100, 10, everything is possible, sir. Am I clear? Everything is possible. It's not like, there is some rocket science or some great questions they are going to ask. This is an examination based on your comprehensive understanding of your undergraduate subjects. Only that is what they'll ask you. Whatever you studied in your undergraduate, you have to study properly. Then you can easily qualify, then you can get good rank and best rank and the top rank. Everything is possible, my dear friends. Am I clear? I have doubt. Any helpful inter-math solving, sir? See, intermediate mathematics is learning stage. Intermediate mathematics is learning stage. Whereas engineering mathematics is application stage. We have to review intermediate mathematics. You cannot completely do your 2 years mathematics and come and join this, my dear friends. You should know how to review things. Am I clear? So definitely it will help. See, math PRT generally, the calculus, linear algebra, probability, they'll give you highest, and of course discrete mathematics for computer science students. Okay. See, for mathematics there are around 4 marks you can get, 4 to 5 marks sometimes. Discrete mathematics will go around 12 marks, my dear friends. So 15 to 16 marks you can score if you learn mathematics completely. Here mathematics, the questions for computer science students are very simple, believe me. The very simple questions you get it. Only in probability they will combine that questions with, together with graph theory they can combine with algorithms, or they can combine with data structures also. Even theory of computation also they can combine. Okay, they can combine with networks also. See, probability can be asked anywhere. It can be combined with any subject, and that combination is more when it comes to computer science students. Am I clear? For computer science students, the combination of probability questions with other subject is more. Whereas if you go for any other branches, probability just need to study as a probability because simply mathematical teacher will give you those questions. But here, any any computer science faculty can give you a mathematics question. Probability, they are all needed, very much needed for the subjects, my dear friends. Probability is needed. Okay, for advanced AI and machine learning concepts, it is needed. The basic idea of probability is needed. Okay, linear algebra is needed. So even the computer science faculty can also ask the question, so they can combine with mathematics and they can ask you. That happens generally with graph theory, they'll ask you probability question. Even in algorithms, binary trees, binary search trees, they ask these questions. Sir. This is possible here. Okay. Syllabus, how many days complete syllabus? Any suggestion, please, sir? See, my dear friends, computer science syllabus is the shortest, sweet syllabus. You can complete that in a very limited time if you properly plan it. 6 months, 5 months also people cracked GATE with good ranks, flying colors. Okay, 4-5 months serious effort is enough generally for computer science. Now you are having 7 months, it is more than enough. Proper planning. And always remember this graph. Always remember this. This is my important suggestion for my friends. Initially when you start with a big ambitions, and later on what happens? You go down. Then towards the end you want to jump. But where you started, where you ended. Almost at this same plane. Okay? So you should do it continuously, my dear friends. Your journey should be continuous. Your effort should be always increasing. Or at least constant effort. You should not be like, once it is very good, then it is going down, like that it should not be. Am I clear? So you should always put effort, continuous effort. GATE is all about continuous effort, sir. See here, in a single day, they'll ask you questions in 12 subjects. So, proper understanding and proper application is needed. Okay? And the understanding of undergraduate subjects. All these subjects you studied in your undergraduation. Actually, in undergraduation, you studied more subjects. Here, very limited subjects. 12 subjects only. Then that some subjects weightage is very, very less. See, hardly if you see 7-8 subjects are, they take little more time. Remaining all subjects will take less time only. So, 5-6 months is more than enough for computer science if you do continuous effort. Your effort must be continuous. It should not be like this, sir. Continuous effort you have to keep. Or at least constant effort. You can write. Okay? Definitely you can crack, you can ace GATE, whatever. Anything is possible, sir. Any other doubts, my dear friends? Please do ask me, sir. Thank you, Prashant Kumar. So after the class, if you ask, I can discuss in a detailed manner, my dear friends. The doubts or whatever things are there, I can ask you, or I can, clear doubts in a detailed manner. Computer science, 5 to 6 months serious preparation is enough. Anyone can ace GATE. Computer science. That's all for today, my dear friends. Thank you. Thank you all.